Okay, now we go to the frequency modulation. Okay, so it is actually almost the same as the amplitude modulation. Okay, for this time, the parameters that we are going to modify here is the frequency of the carrier signal. Okay, before this, in amplitude modulation, the amplitude of the carrier signal will be modified, okay, with respect to the amplitude of the modulating signal. But for this time, for FM, the frequency of the carrier signal will be modified, okay, with respect to the information signal. Okay, so we go through what is FM signal. Okay, frequency modulation is the process of varying the frequency of a carrier wave in proportion to a modulating signal. Okay, so this is the information signal or modulating signal. It's the same. And this is our FM signal or modulated signal. Okay, so the amplitude of the carrier is kept constant while its frequency and rate of change are varied by the modulating signal. Okay, as you can see here, the amplitude now is constant, but the frequency is changing, okay, according to the information signal. Okay, with respect to the information signal here. Okay, but before this, in AM signal, the amplitude will be varied. Okay, but the frequency of the carrier is constant. Okay, but for the FM signal, the amplitude is constant while the frequency will be varied. Okay, so when the information signal is at the maximum negative and maximum positive amplitude, the FM signal is at its minimum frequency and maximum frequency. Okay, you can see here, this is the information signal. So this is the maximum amplitude, okay, maximum positive amplitude. So what happens when this information signal is at the maximum amplitude? So the frequency here will be maximum, Fmax. Okay, the frequency of the carrier wave will be modified to Fmax. Okay, and then when the information signal is at the maximum negative value here, so this is the maximum negative value, so the frequency of the carrier wave will be minimum. Okay, and so on. Okay, it will be changing from the maximum frequency to the minimum frequency. Okay, so this is how FM signal will be produced. Okay, so here are some calculation or equation that can be used in the frequency modulation. Okay, so for the modulation index, okay, modulation index for this FM signal, it is the ratio between frequency deviation and the maximum modulating frequency. Okay, so we have a new terms here, which is frequency deviation. So this is the symbol for the frequency deviation. Okay, and the maximum modulating frequency is this Fn here, okay, which is the frequency of the modulating signal or information signal. Okay, so the ratio between frequency deviation and modulating frequency will produce the modulation index. Okay, so frequency deviation, okay, so the meaning of this frequency deviation is the maximum change of the instantaneous frequency of FM signal from the center frequency. Okay, so it is proportional to the amplitude of the modulating signal Vm. Okay, so for frequency deviation, okay, one equation here that we can use to calculate the frequency deviation is equal to Kf times with Vm. Okay, Kf is a constant value, okay, constant value, which is called the frequency sensitivity. Okay, and Vm is the amplitude of the modulating signal. Okay, so Fmax and Fmin can be calculated from the carrier frequency and also frequency deviation. Okay, once you obtain the value for the frequency deviation and also the carrier frequency, okay, we can calculate the value for Fmax, okay, which is this one here, the maximum frequency, okay, when the information signal is at the maximum amplitude, and Fmin here, okay, which is when the information signal is at the minimum amplitude. Okay, so Fmax can be calculated from this equation here, which is Fc plus with delta F. Okay, Fc here refers to the carrier frequency, and Fmin is equal to Fc minus with delta F. Okay, so the difference between this Fmax and Fmin is called carrier swing. Okay, the total change of FM frequency is called carrier swing. Okay, so carrier swing can be calculated from this one here, Fmax minus Fmin. Okay, or you can simplify F carrier swing is just equal to 2 times of frequency deviation. Okay, so these are the block diagram of FM transmitter. Okay, so inside the FM transmitter, there will be FM modulator. Okay, so this is where the modulation process will be occurred. Okay, in producing an FM wave, the frequency of the carrier signal is modulated or changed by the modulating or the information signal in the FM modulator circuit. Okay, so you will then produce an FM signal here. Okay, it is amplified by the radio frequency amplifier before it is transmitted and broadcasted through transmitting signal. Okay, so this is very simple block diagram. Okay, and then FM demodulator is just the reverse process of modulator. Okay, so this one occur in the FM receiver. Okay, it is located in the receiver to recover the original information signal and pass it on to the user. Okay, so what will be received here is the FM signal. Okay, which is the modulated signal. Received from the FM modulator. Okay, so the FM signal will become inside this amplifier, okay, and mixed together with the local oscillator, and it will be amplified and filtered, okay, FM limiter here, and then it goes to the demodulator, and then it will amplify again, and it will be transmitted to the destination. Okay, so that's all about the FM signal. Thank you.